All right, so your assignment 3, just make sure start in time. For your Milestone 2 meeting, meetings already signed up is done, but for the submission, it will be similar to last time. So I'm going to send you a PDF just to confirm what you have to submit, but most likely you just have to submit the whole project as a zip, and then make sure you actually include the required files. I'll make it very explicit once I release the PDF. So you definitely got time to make sure you can check. And for your project report template, there's still one section there. I would like to give a little bit more details about what you can write. So what I will do is I'm going to release that before Tuesday's class. In the beginning, on Tuesday, we're going to go over the template together, so you know exactly what to write. Okay? Okay, so that's about the reminders for the course. Okay, so presume you guys are okay. All right, so for today, we should be able to get very close to the end of the top-down parsing. So there will be one concluding remark of the top-down parsing I would like to do on Tuesday, so we can make a smooth transition into the bottom-up parsing. That's the plan. And also, I'm going to distribute some exercise. I'll do that maybe tomorrow. I'll release some PDF. You can do the exercise about the first, and we'll talk about something called follow set today. So you can also do the exercise. That will also help you get prepared for the quiz number 5, the final one. All right, let's now talk about lecture materials. Okay, let's see how much time it will take. If we can finish earlier, we finish earlier. Okay, so we talked about this algorithm last time about calculating the first set. So this is the abstract definition, and that's the algorithmic specification. We also did the detailed tracing together. Okay, that's something we did last time. And today, before we actually talk about the need for another set called a follow set, we want to just do a little bit of extension about the first set, which is kind of implicit already in the algorithm. Right? So if you recall from the algorithm, you can also check the input over there is simply a single variable or a single terminal. What do I mean? So if you recall what we did last time, I'll show it to you very quickly. When we actually calculate the first, for example, we say the first of some expression prime, which is a single variable. What we want to see today in the beginning, what if I want to calculate the first of this entire rule, which consists of a mix of symbols and also variables? That's something we want to see. That'll be very useful, actually, when we later on want to put everything together to get the backtrack-free algorithm. Okay, we'll get there. So the first thing to clarify is the first set calculation originally that we talked about on Tuesday is only a single variable or single terminal. What we want to do now is to have something like a star, meaning that we can have the right-hand side of the rule. And the calculation is actually very straightforward, but I'm just going to use this opportunity to recap very quickly how we can do the calculation. And sorry about this part over here. I will make sure I fix the slides, but on the iPad page, it's actually fine. So let me just switch there, and then we'll just look at some example quickly. The name of the extended function is still called first, but whenever you got the first over here, if you see only a single variable or single terminal, you would know it's the original version. But if you see a list of variables or list of mix of variables and terminals, that'll be the extended version. Let's take a look. Okay. Let me, first of all, actually go over this definition with you very quickly about the first. Okay? And let's remind ourselves what first is really about. Whenever you're given beta 1 can be a variable or a terminal. Right? The beta over here can be a variable, or it can be a terminal, either way. And when you say you want to calculate the first set of this or this, what do you really mean? You're saying that if I try to derive this particular variable further, what will be the first symbol I'm going to observe? What will be the possibility? By using the list of possible derivations, we will be able to avoid backtracking. So that's kind of the intuition we had before. And in the terminal, it's simply no-brainer. Whenever you see a terminal, that'll be the first symbol you see. There's no further derivation needed, right? So these are the two possibilities that we talked about last time. And now let's say, rather than having a single variable or a single terminal, what if we have a list of mix. Beta 1, beta 2, all the way to beta n. All right? And you will see we're just doing a list of union over here. Okay, you definitely need to spend a little bit more time after class to think about this formulation. And that's a set comprehension, apparently. I'll give you some insight here right away, and then we'll do some example. Okay? Number one, you want to see we got from 1 to n. We got n components as the argument. And then here, when we talk about union over here, we only go from 1 until k. And there's a reason for that, right? Under the condition that we're saying that every beta from 1 until less than k, that means k minus 1. What we're talking about is from beta 1, beta 2, and also all the way to beta k minus 1, right? That's something you can read right away. What would be the common property of the first k minus 1 components? We're saying that they are nullable. What will be the consequence when these components are nullable? For example, let's say, let me just write it down again so you can see it more easily. If I got A, for example, produces beta 1, beta 2, all the way to beta k minus 1, beta k, all the way to beta n, right? That's the original input. Let's say up to this point over here, every one of the components are just nullable. And if you recall what we did, in order to remove the null production, when we say nullable variable, that means you have to think about either this component here is there or it is not there. When it is not there, you definitely have to consider the first of beta 2 as well. And where beta 2 may not be there, you also want to consider beta 3, and etc. So there are 2 to the power of k minus 1 possibilities over there. Okay, so that's kind of the intuition. So what we are saying is, if we know that from 1 until k minus 1, each one of them is actually nullable, then we can definitely union all their first set together because they are all possible to be observed as the first symbols because their previous one may just be nullable. And this will be some very useful insight when we calculate the follow set a little bit later. Okay? And of course, if you see on the slides, you will see beta k is the first one where it's not nullable anymore. That means you cannot really go any further. Okay? Think about this intuition when you study the slides. Right? This will be the first components that's not nullable. So we don't have to collect the first set any further. Nullable. So that means no need. And we're going to do examples right away. There's no need to collect the first further. Okay? So this will be the first one. So that means we stop there. Okay? Let's now take a look at some example. And you will see on the slides over here, the first one we want to calculate is this. What will be the first of this? Number one, you want to observe that we are trying to calculate the first of not just a single variable. We actually got 2 components here, term followed by expression prime. Right? So what should we do here? This is a very simple case, but let me give you a little bit of intuition here. In order to calculate the first of this particular list of components, we want to know what's the first of term for sure. That's going to be observed. When should we consider also the first of expression prime? When term itself is nullable. Okay? So let me write it down here. So the first one. So when you want to calculate, for example, the first of term followed by expression prime. Okay? You definitely have to consider for sure the first of term. In order to see what you can observe from this particular list, definitely the first one to observe will be the term itself. That one's for sure. But should we also consider the first of expression prime? We only consider this if the term itself is nullable, meaning that there's a possibility that this part here is derived into epsilon, in which case we have to figure out the first for expression prime as well. But is this the case over here? And what we assume is you already know about these two tables which we calculated last time. So if you look at the first of term, if you look at that here, the first of term, do we have any possibility of epsilon over here? We don't. We either got closing, opening parenthesis, or we got some identifier, or we got some number literal. So none of them will make the term nullable. All right? So that means in this case, I'm going to make a note over here. Expression prime over here, not nullable. Or to be more precise, epsilon is not a member of the first of expression prime. So in this case, that's all we have to calculate. Okay? What would that be? That would be just the first of term, which would be all these. This, the name, and also the number. That's what you will see over here. Like that. All right, are we okay with that? William, go ahead. Question. Huh?
I feel like at some point you said that expression prime is not nullable.
Turn. What I really meant to say the turn. Yes, I meant to say turn. Yes. Okay. Maybe I did it. Okay. In that case, I really meant to say, okay, let me say that again, just in case. Maybe you're right. In order to calculate the first of this particular list, you definitely have to include the first of the term over here for sure. And you want to make sure, oh, I see. I see what you mean. You only get to this if the term itself is actually nullable. Okay, I see what you mean. Let me just write it down here. You're absolutely right. Let me just correct this. That's absolutely right. Okay, that will make more sense, wouldn't it? So here, the term, as you can see, is exactly over here. It is, term, not term prime. The term over here. Okay, you can see the term here is not nullable because epsilon is not in the first of term. That means you don't have to consider expression prime first. You don't have to. Only consider that. Good. So the easiest way to remember how to calculate this is to see, start from the leftmost. If the leftmost is not nullable, you stop there. If it is nullable, you have to keep going until you reach a point that you hit a wall, meaning that it's not nullable anymore. Just remember that. All right? Let's now take a look at another example over here. What about this? Guys, how do we calculate the first of this list over here? Let's follow the same principle, right? There are 1, 2, 3 components over here. We always should include the first of the first components. The first of plus will just be a plus. That one's easy. Should we also collect the first of term? Should we or should we not? Shafan, should we? Should we collect the first of term in this case? Okay, maybe William. We're done there. Exactly. It's that easy. Okay? All right. Again, just repeat. In order to calculate this, you want to always include the first of the first components. If it's already a terminal, you definitely don't have to continue further. If it is nullable, you have to continue. Okay? Like that. And this one will be done similarly. Because minus is a terminal, you don't have to collect the term over here. Right? You already hit the wall, so you don't really reach any further like that. Okay? And this epsilon here would just be epsilon. Okay? But I believe do I have any other example over here? You know, there's something we can take a look. Give me a moment. Term prime. That's okay. We can look at the exercise sheet maybe for later. But, okay. Are we okay about the computation for the extended first? This will be something we assume we're going to be doing. Okay? So this will be the first calculation, and we have to now realize this itself may not be enough for the backtrack-free grammar. We need something more. But let's see why, and then we'll get to that second set. Okay? Okay, let's see this. Okay, is the first set really sufficient? And this is actually something we did earlier in the lecture for the tracing about the top-down processing. But we're going to look at that a little bit later. But let me go for a little bit more bullet points just to see why first set is not enough to ensure backtrack-free. Let's say this. Let's say we have these. This particular expression prime. Let's say expression prime has three alternatives. Either we can do plus, we can do minus, or we can do epsilon. All right? And we know pretty well from before the first of this particular alternative. Okay, let me just do this. Some very quick exercise you can just do on your own, but that's something we already did as a preparation, right? You can say, in order to figure out what the consequence of using this rule, we know the first of that is simply just plus. We know that the first of the second alternative over here is just minus. Okay? And the first of that, the third alternative is actually epsilon. Okay? And this is really a special case that we may want to handle. Of course, by the way, one may argue that before you actually treat the grammar, you can always remove the epsilon production, like what we did earlier. But sometimes you may still be given some grammar with the epsilon production. That's also another possibility, right? That's why we are talking about this. This is problematic. Okay? Why? If this is only epsilon, we cannot really make a decision right away whether or not the focus is matching the word. Because the epsilon over here, if you kind of recall what we did earlier for the tracing, I'll just hand wave a little bit so you can definitely refer to what we did earlier. Let's say this is the epsilon, okay? And the current word is actually plus. So we don't really know whether choosing this epsilon is really going to hit somewhere that's going to have derive into plus. We don't really know. We wouldn't know until we actually get to maybe several backtrack steps until over here, and then go from there and see if plus can be derived or not. If it is, we're lucky, then we hit. If it is not, then we have wasted resources doing backtracking. So wouldn't it be nice if we can avoid that kind of backtracking? So the idea would be, we want to say, considering first would be useful, for sure, in these cases. But wouldn't it be nice to say, what about after expression prime is derived? What can come after that? So this is a new concept that we want to learn. Before we talk about the first is about what are you going to see right in the beginning. And we're going to consider another one would be what would you see at the end after the derivation. So that one there is going to help us to actually save some backtracking in this kind of case. Right? That's what we'll see. All right? So from this one here, we say it would be nice. Useful. Useful if we can know what symbols follows. So this will be the keywords. Follows expression prime. Okay? So this is the new bits that we're going to learn before we can actually have a backtrack-free grammar. Right? So we have done the first, and we have seen the motivation for the first not being sufficient. So now we're going to talk about another new set called the follow set, and we're going to calculate it. The way it's going to be calculated is not too bad. I would say in some way it's going to be calculated in a very symmetric way as the first set. So I'm going to show you the algorithm. We'll do some example together, and then we'll see how to put them all together into the grammar. Okay? Okay. And for the rest of the slides, it's basically just about the motivation. why we want to do this. Are we okay so far? Up to here. All right. What we want to do now is to see this new set over here. Right? So ultimately, you're going to see 3 sets in total. So you want to really know what they are really meant for. The first is really by observing what can come first before the derivation. Follow will be what can come after the derivation intuitively. And there will be another set which we're going to define in terms of the follow and the first. We'll see. All right, let's take a look at the intuitive definition. It will be the set of symbols that can appear to the immediate right, like after the string derived from V. Right? Of course, the argument for the follow will just be a single variable. Okay? Or we can generalize it into a mix of symbols, like what we did to the first. This will be the abstract definition. Let's now take a quick look. Okay? For now, we're just going to talk about variable. Okay? Let me use a different color here. Whenever we want to calculate a follow set for a particular variable, what would that be? Okay? It's going to be all such words, W. So what will be the condition for W? You can see W here is simply sigma star. So it's terminals only. First of all, it's terminals only. It does not contain any variables. Terminals. Over here. Okay, and let's take a look. V over here is the argument we pass. If the V can somehow be derived into some string X. Okay? And then this will be the start variable over here. And this will be the start variable. And then take a look at this particular string. Okay? You can see here X over here is derived from V. And W is just another string that follows the derivation of V. A string that follows the derivation of V. And what about the Y here? Y here is just for pattern matching, just a rest of whatever the derivation is. Okay, let's recap what the definition is telling us. Whenever you're given a variable V, you want to calculate all its follow symbols. It's going to be all such words, such that after certain derivation X of V, there will be a words that follows that. That will be what we want to calculate as a follow symbol. Okay? And you can think about the way we calculate this follow set here is going to be very symmetric to how we calculate it first. Rather than calculating from left to right, we're going to calculate from right to left. That's going to be how we're going to do it. All right? And let's have some intuition over here. Okay? I already got answers about the follow over here. Okay? We can go over a few of them just to get some intuition, and then we'll see how the algorithm should work. But before that, we're going to do a little bit preparation exercises just to make sure you're okay. Okay? And whenever you want to calculate a follow, there will be some very important assumption. We're assuming that you have already calculated the first set. It's available for you to use. Okay, I'll write it down. Important assumption. Important assumption. The first is already computed. Okay, that's really important to note. And I just put it here. This will be the first over here. All right? So as we go over them one by one, I'll see how many we should go through. At least we'll go over the first few, and then we'll see. Let's start with the expression. What will be the follow for expression? Okay? The way to think about it is you want to find every occurrence of expression to the right-hand side of each production rule, number one. Okay, let's find it out. You can see over here, expression appears over here. Okay, let me make it thicker. The expression here, and we got another expression over here. right? We got 2 occurrences. Only look at the right-hand side occurrence. You don't need to look at the left-hand side, okay? Of course, it's a little bit different. Before, when you calculate the first set, you have to look at the left-hand side to look for the variable, to calculate it first. But now for the follow, you have to look for their occurrences on the right-hand side. That's something to note, okay? And let's start with this one. This one is rather easy, okay? We are saying somehow expression can be derived to something. What can follow that? Well, this guy here. That was obvious, right? Okay, so that's why you see this guy over here. Okay, that's why. Number 1. Number 2, given that goal is the start variable, we assume that at the end of the entire derivation, there will be an EOF, end of file symbol. That's always assumed. Okay. So you can think about at the end, there's always an EOF, always. So that's why you will see EOF over here, and also the closing parenthesis because of this. That's how you can interpret the follow for expression. We can look at a few more. Okay, let's look at a few more. What about the second one? Let's look at expression prime. Expression prime here, here, and also here. I believe these are all the 3 occurrences, right? We got only 3. We're going to consider them quickly. Let's first of all consider this one. This is like a special case in the sense that expression prime happens to be the rightmost components of this particular production rule. So what follows expression prime would be just the same as what follows expression. Do you see what I mean? Let me show you. If I got expression over here that can produce turn, follow, expression prime. So think about what can follow this. They can also follow that. Okay, that'll be something to remember. Okay, that will be something you will see from the algorithm too. Okay, I'll put a mark over here. So this is why you will see. Let me use the green. You will see for expression prime, we simply inherit EOF and closing parentheses. So these are simply just the follow of expression, because expression prime happen to be the rightmost component of expression. And what about these 2? Similar, expression prime should be the same as what follows expression prime. Well, it has no effects. All right? And that's about expression prime follow. Right? I think this kind of intuitive walkthrough kind of gives you some idea what the algorithm will actually do. I'll show you different parts in the algorithm. Okay, and then we'll do a little bit more mechanical calculation. Okay, let's do maybe another one. How about turn? Again, let's identify all the occurrences for turn. So we got here, and anything else? We got here too. Okay, guys, this one's interesting. Okay, especially I want you to actually look at this one here. Oh, you know what? Let me use the same color. Okay, let's look at this one here. Now we want to calculate the follow of the turn. That's what we want to do. Okay? Turn is not the rightmost components. So in order to observe what can follow the turn, we don't necessarily can just calculate the expression prime its follow. It might work, but in general it may not work. So let's see in this case specifically. If you look at expression prime, okay? Expression prime over here, if you look at its first, which we assume exists, it includes epsilon. What does that mean? That means there is a chance turn may be the rightmost components of expression if this happens to be null, given that its first includes epsilon. I hope you're following the logic here. All right? In that case, turn, the follow of turn is going to inherit everything also from the follow of expression, for sure. I'll write this down a bit. So here for the turn, so that will be EOF, and also this one here. So these two, okay? So these two are simply the follow of expression. So that is, we want to calculate the follow of turn. It turns out the follow of expression should be included there because this rightmost components may be nullable. So that's why it can also follow. Okay? So that one there is simply follow because the first of expression prime, which is over here, the rightmost, contains epsilon. All right? That's something you can also look at. Okay? And these two will follow very similar logic over here. And we're going to maybe look at them maybe when we calculate using the algorithm. That's something we'll do. But I think intuitively, you have seen quite many interesting rules already. Let me recap very quickly. Okay? Only look for, if you want to calculate the follow of certain variable, only look for the occurrences on the right-hand side of the production rule, number one. Number two, if the variable happens to be the rightmost, in that way, inherits the follow of the left-hand side over here. Number three, if somehow the variable happens to be in the middle, not the rightmost, in that way, you have to look at the previous one. If they all happen to be nullable, in that way, you have to include this one as well. Okay? So we can definitely generalize this a little bit further. That's something we will do. Okay? Okay, hopefully the intuition, if you got 50% understanding, I would say that's not too bad. Okay? Okay, so what we should do next is to really go over the algorithm. Okay? Let me see. We're now here. Why don't we take a very short break by taking attendance? And then we're going to dive into the algorithm. How about we do that? Okay. Okay. Clicker. Yep. Let me just refresh the location very quickly. Attendance. Oh, settings. And then attendance. Don't require. Good. Save. Oh, sorry. I think that should be enough. Start the class. Oh, good. Okay, you can now check in. Oh, actually, for that one, you don't need to see. Okay. Yeah, just make sure everybody check in. If you got any trouble, come forward as usual. Okay. Can I stop the polling? Everybody's okay? Yeah, okay. I'll wait for you. That's okay. Yeah, guys, meanwhile, take a break. I think today we might just need 2 breaks for you. After the break, we'll talk about algorithm. After that, we'll take a little break, and then we'll talk about final thing. Okay? I want you guys to stay as sane as possible. All right. I'll stop it now. Okay, take a 3 minutes break, all right, until 3:13-ish. Hmm?
You get the mind quiz.
Quiz number 4?
Yeah.
I'll check my email and I'll let you know. Okay, I'll let you know. Yes, I should. You already sent it, right?
Yeah, yeah.
I think I should have got it.
Yes,
Yeah.
it does.
I'll check. I'll check. My bad.
Oh, it's okay.
Do you think you might be able to come with me to my office after class and then I'll give it to you?
Yeah, I can.
Okay, sounds good. Just go with me after the class. Okay.
Well, I mean, the only real problem is that I think because it's all the chapters, a lot of the model customers will know. Yeah. So, like, for example, let's say you visit a practical course. It's going to be like, well, I have to visit the summer. Yeah.
Do I not check if it's an instance?
You do, but sometimes it's else. Else is probably where all the which so either you need like a bunch of if statements or you just have this clever built-in.
I didn't wear the contact lens today and the power of
Oh, okay. That's okay. That's okay.
Actually, you know there was you can build folders using those.
I don't think we've done that for you, but you hold on.
Yes, that's what I mean.
Yeah, that would have been better. I don't know why I didn't.
The reason I think about that is because the great thing was autocomplete. I'm like, is that a function that gives me everything?
One difficult thing, like whoever's working on the value needs to do, is pass all of the function call arguments, pass them into the first.
Okay, 1 more minute and then we'll resume.
That's something they evaluate. Because what I'm checking right now are the same types. Semantic check, type check, but we need to like transfer the values onto it. That's good.
I would say for all C uses, all functions, at least for the processor that defines all the definitions or paths, once you hit a function call, that's considered one of the C's and it doesn't look inside the function.
Okay.
But the evaluator does have to look inside the function to actually put a function. But like, all of the
Yeah, let's resume. Yeah. Oh. William can finish that if you want to. That's okay. Awesome. All right. Follow set. Okay. Before the break, we talked about just intuition. Now we make it more precise. Okay. And I will highlight certain lines you should really look into a little bit more when you can stay by yourself and then to convince yourself. But what I want to focus more is to show to you in the test how you're supposed to figure out a follow set. I think that might be more relevant. But of course, for the algorithm, you should also try to understand the line. Okay, and let me see. Okay, that's fine. Okay, good. Okay, the algorithm, quickly. Okay, not many lines of code, and I will get you guys ready as well by some warm-up exercises before we get to the actual example. The input, okay, by the way, the algorithm is about get follow as opposed to get first. We are given certain grammar, okay, and what we really want to calculate is a map. Remember, we talked about the first being more like a map. Given certain variable or terminal you want to return, it's set of first symbols, similar for the follow set. Okay, so it's a map or mathematical function. So this part tells you it's more like a map. Given the variable, we want to figure out its set of symbols being its follow symbol. That's basically the input and output. And initially, the follow set for all the variables is simply just empty. That's easy. And there will be some very important case to start with. The start variable has the follow set containing EOF to begin with. If you remember that little case we talked about, for example here, The goal is the start variable itself has always got EOF at the end, always. Okay, just remember, that's what we should start with, always. And just a little reminder over here, this is the start variable. And this part over here, like a last follow, initially empty, and then we want to check to see while the last follow is not equal to the follow, and the same idea. What we really want to get into formally is get to a fixed point about the calculation of the follow. We'll put it a little bit more intuitively. For every iteration for the while loop, we want to do some updates to the mapping of the follow set or the follow map over here. If there was any updates to the follow, in that case, the last follow and the follow wouldn't be the same. That means we have made some progress. On the other hand, if after the entire iteration, we haven't really changed the follow set, that means we have reached a fixed point. The follow's value is simply just stabilized. In that case, we don't really go any further. Okay, that's kind of the idea. Right? So it can be guaranteed it's always going to terminate. All right? At some point, we definitely can finish the calculation. And what about this part over here? Right? I'll highlight certain parts that you should really watch out for, and then we'll see some warm-up exercises. We'll do that together. Okay? So number one, you can see we have some nested loop. But this one here is simply say we want to check for every rule in the grammar. So that part there is not that important. This is what's important. Notice that we go from k down to 1 rather than going from 1 up to k. That's the first thing to note. That means for every rule that we have over here, unlike the first set, in which case we try to calculate from here, and then maybe we have to keep accumulating if they are nullable. Now we go backwards over here. So we start with beta k with something. And then if this is nullable, we have to accumulate it and include it as a follow for the next, the previous one, and etc. So we're going in this direction. So that's why you see k down to 1. Okay? But exactly how to do this calculation here, I got some warm-up exercise for you. Bear with me. So this one here, we just go from right to left. Go from right to left for the computation for every rule. And over here, we got certain calculation here. And when you study the algorithm, I want you to pay more attention about this variable called trailer. Okay? Trailer here, and trailer here. Okay? I wouldn't really trace it faithfully when I do the example. We can easily get lost, including myself. So, but something you may just want to convince yourself it is really doing the trick. But we'll do a little bit more intuitive tracing, hopefully. But what you want to really notice is for this particular case, okay? And for that one, I'm going to make a sub-remark, and then we'll do exercise after that. Okay? So what I want you to pay attention to is this part here. Okay? This part here. We are checking to see whether beta I is nullable. Is beta I nullable? Okay? If it is, we do something. If it is not, we do something else. All right? If it is nullable, then we want to accumulate if beta I is nullable. Accumulates its first for the follow of beta I minus 1. Right? It's a very precise remark, but you can convince yourself that actually is the case. What we are saying is this. If beta I happen to be nullable, that means when we calculate the follow for beta I minus 1 in the next iteration, we should include the first of beta I because it's nullable. right? Otherwise, we don't include it. Okay? Okay, for this one here, if beta I is not nullable, then don't include its first. Okay, that's a sound remark. You can actually look at them maybe later after we have done the example. Okay, and we're going to do two exercises together, but I'm just writing the question over here. So this will be something you will have to figure out in general. Okay, let's say this. If this is the rule that we are currently considering, okay, so we should definitely consider beta k. What will be the follow of beta k? And this is actually some special case we talk about, remember? Because beta k happen to be the rightmost components. So the follow of beta k should be the follow of A at the same time, right? That's something we did before. Number one, I can definitely put it right away. It would be the follow of A for sure, okay? Now, we want to calculate the follow of beta k minus 1. What will be its follow? We have two choices. Either we have to include the first of beta k, or we don't have to include, depending on whether or not beta k is actually nullable. All right? That's something we have to watch out for. Okay? Why don't we take a look to see what's going to happen here? Okay? Let's say we got this. I'm going to write it down precisely. So let's say A produces, let's say, only 3 components. Beta 1, beta 2, and beta 3. Okay? Over here. We got 3 components here. And we got different cases. And here we're just enumerating about beta 3 and beta 2. We're talking about this one here and also this one over here, right? These two. Okay, these two. And beta 3 may or may not be nullable in general. So 2 possibilities. Beta 2 may or may not be nullable, also another 2. So we got 4 possibilities, 4 cases to consider. I'll just talk about only 2 cases. For the other 2, you can definitely fill the gap for yourself. Okay? Let's talk about these 2 cases quickly. What will be the follow of beta 3? The follow of beta 3 over here is actually quite obvious. Well, since it's the rightmost symbol, it will be just the follow of A. And this will also be the follow of A because it's simply just the rightmost symbol. That part is actually the same. Okay? And how do we calculate the follow of beta 2? Okay, let's talk about this case. Here we say that the epsilon, let me just rewrite this rule. So here we talk about A produces beta 1, beta 2, and beta 3. And we are making the assumption that beta 3 is not nullable. Okay, so we are making the assumption that this is not nullable. Okay, so what we should do is, what can really follow beta 2? Whatever that can also follow beta, oh, sorry, let me say it again. Because we know that beta 3 is not nullable, so that means whatever you can see after beta 2 will just be the first of beta 3, for sure. Okay? So this one will just be the first of beta 3. You can think about that's all we can see over here. This will be the follow of beta 2. Okay? Now, question is, should we union that with the follow of beta 3? This is a question mark. Right? We shouldn't in this case because given that beta 3 is not nullable, there's no possibility of beta 3 to become null. In that case, what follows beta 3 is not relevant to what can follow beta 2. Right? That's kind of the logic you want to get through in your mind. So we don't include this. I wrote it there just so that you may want to consider in some cases. Okay, let's now go a little bit further. What about if we want to calculate the follow of beta 1? Okay, and we are assuming that beta 2 also is not nullable. That's also something we assume. So beta 2 over here is also not nullable. Okay, can anybody try to see what should be the follow of beta 1? Swap. I agree. Should we include the follow of beta 2? No. Because it's not nullable. Absolutely. Okay? If you are getting a little bit closer to that kind of intuition, that's a good sign. Okay? Given that it's not nullable, so the only thing we include would be just the first of beta 2. Okay, just that. This is more like an extreme case where somehow for every symbol over here, its next symbol is simply just not nullable, so that you cannot really accumulate the trailer from the algorithm. Okay, that's something you will see when you study more closely on the algorithm. All right, how about just do one more case before we start tracing the algorithm a little bit more closely. How about this? So guys, I'll give you just maybe 1 or 2 minutes. Let's say, let me just write down the rules once more. A produces beta 1, beta 2, beta 3. And we are making the following assumption. Both beta 3 and beta 2 are nullable. There's a possibility that they might be null. Nullable. And this is also nullable. Okay? This might be the case where we have more union to actually compute. Okay? And we already got this starting point. The follow for the rightmost symbol is always the follow of the left-hand side. Okay, so you guys can think just for 1 minute, what would be the follow of beta 2 and also beta 1? Think about it. Okay? Okay, just 1 minute. Thinking ahead, or if you want to write something down, that's okay. And then we'll try to work this out. Once we have done this, I think we got enough warm-up to actually trace the actual grammar. All right. We can start with maybe beta 2 over here. What will be the follow of this? You wanted to volunteer? Okay, yes, go ahead. What should that be? Yeah, I agree. Yeah, absolutely. First of all, for this symbol here, you always can be followed by the first of the next symbol. That one's for sure. So that'll be the first of beta 3. Yes, I agree. First of beta 3. He also said something else. What was that? Mm-hmm. Exactly. Yeah, absolutely. That's right. I agree. Guys, what about follow of beta 1? Maybe a little bit longer to write, but think about it. Because now we got a case where beta 2 could be nullable, and beta 3 can also be nullable, right? We want to union all the possibility together. Yes, go ahead, please. Okay, so of course we're talking about here, right? First of beta 2. Yeah, exactly over here, right? Okay, absolutely. The union, okay, so when this is actually null, then we can definitely see the first of beta 3. First of beta 3. And also when this is also null, we can also see the follow of beta 3. And of course, follow of beta 3 is simply just a follow of A, which is over here, which we can also look up in the map. All right? All right, guys, I hope at least this will give you a little bit of intuition. And let me make one more connection, and then we'll trace on the actual grammar. The way we actually work out what should be union is something called trailer when you see the algorithm. Okay? This will be the value of what you see called trailer. Should be single L, I'm not so sure. Whatever, maybe double L. Okay? If you see the algorithm over here, basically, you will just try to keep accumulating the trailer, either with the first or without the first, basically. And then, depending on whether it's nullable, that's basically what you do. And go backwards from k down to 1. All right, that's something you can see. All right, now the actual calculation. Okay. I think for this one here, I still put the algorithm over here, but we don't necessarily have to really trace it line by line. We can easily get lost. As long as you already got the intuition from here, it should be quite straightforward to calculate. But let's try. Okay? And I put down some guidance over here about how you should really do it. And for now, I just choose this particular order to actually do it. And if you choose a different order, it will still be okay. But it might be just be that you might need a little bit more iterations to actually get to the fixed point when it gets stable. But let's choose this one. Okay? Let's choose this particular order. Before that, let's now do some initialization. Okay? So what we'll do is, let me first of all try to just execute this part over here. You can see that's the preprocessing before the loop. The follow of every variable is just going to be empty. So you can see nothing here, right? All the variables, nothing here. And then the follow of the start variable, which is go. Okay? That one there is actually just going to be EOF. That's what we start with. Important. That's a starting point, right? And then we're actually going to go variable by variable. Of course, for every variable, we'll also go production by production. Okay? Let's follow this particular order. The first one. Let's say the go. All right? So we're going to look at this particular production. And one more thing to mention. Okay? Let me just go back to the algorithm. It's easier to see. I will write it down too. You can see here, whenever we are considering a rule, A produces beta 1 all the way to beta k. That means potentially we may have to update k entries in the map. We may have to update a follow for beta k. We may also have to update a follow for beta k minus 1 and all the way to beta 1. That's something we have to update. Okay, I'll write it down. It's important to notice. Okay, I'll put down here. When considering this rule, follow the map may need to be updated. Updated for k entries. Namely, beta k minus 1, beta k minus 2, all the way down to beta 1. All right, just remember that. Okay, let's now go back here. Okay, the first rule. We are considering go produces expression. So potentially we can only update the follow entry for expression. Okay? What should we do with this guy, given our warm-up exercise? We are lucky for this case because number one, there's only one component to consider. Also, that component is immediately the rightmost components, right? So that means the follow of expression would just be the follow of go. Agree? Okay. So we just put EOF. That's all we do. Okay? And of course, that will be the only iteration we run, just one variable. And we're done with this. All right? Let's go further. Let's say we have the next one. the factor. All right. Let's now go over this one specifically. Let's say factor. Okay, let me just watch out the tongue. Okay, factor. And for factor here, let me give you a little bit of notes, hints over here. Beta 1. Oh, I don't want to actually, okay, let's say beta 1, beta 2, beta 3. And for beta 3, it's not really a variable. We don't need to update anything. And what about expression over here? What should we update it into? Well, expression over here is beta 2. In that case, it will definitely be the first of beta 3, which will be closing parenthesis. Do we also need to union with the follow of factor? That's important to note. Can somebody tell me? Henry. It's not nullable. Thank you so much. Absolutely. So guys, if you're not too sure about this, definitely make sure you review that. Henry just said exactly what you should know. All right? All right, so now for expression, what we should do is we should really extend the expression over here just by closing parentheses. That's all we do. Okay, so I'll make a little bit notes over here. This will just be the first of closing parentheses. All right, and that's it. Okay, and for this alternative over here, nothing to update, it's just a terminal. And here, no variable to update for the follow. We're good so far. Right? You can see so far we haven't really reached a fixed point just yet because we're still updating. Okay? And the next one. Let's do a little bit, maybe one or two more. And then once you feel more comfortable about it, you can just complete the rest. Let's say we do this. Expression. If we do expression over here, this one here. All right? One thing to note. Potentially, we may have to update the follow entry for expression prime and also turn, potentially. Okay? Expression prime, the rightmost components should be the follow of expression. We know the follow of expression already over here. Just copy that. All right? Let me use maybe green here. So the follow of this will just be the follow of expression. That means we're going to copy EOF and also closing parenthesis, which is right here. All right, that's what we start with. And then what about turn over here? All right, turn for sure is going to copy the first of expression prime. This is something we know. All right, it's going to be plus and also minus. And question, should we union it with the follow of expression? Swap, would you say yes or no? Or you want me to repeat the question? How about I repeat the question? I think that's important. Okay, so now we are not, okay, let me repeat the question and then also for everybody else. We are now calculating the follow for turn over here. For sure, it's going to include the first of expression prime, which we know is plus and minus over here. Now the question is, should we also include the follow of the expression? Should we or should we not? For that one, you may want to look at whether or not this can disappear. Can it disappear? It can. How do we tell? Because expression prime over here is nullable. All right? So guys, it's really important for you to see that, right? Okay. All right, so we also do that. And we also got the follow of expression, which will be exactly here. EOF and also, EOF and also parentheses. And for this one here, I would like to make a notes for your review. This part over here is simply the follow of expression prime because it is nullable. Okay? I would suggest we do just one more, and then the factor can be left as exercise for you. In case you got trouble, you can definitely reach out to me. Okay? Why don't we do just one more? Okay? So far we got 1, 2, 3, 4 calculated. Okay, 1 so far. Why don't we do, so we are now done with term. Okay? Term is actually done. Why don't we try to do term prime? Okay, for term prime. And for the term prime over here, let's see where we have. Okay, it's actually here. Term prime. All right. And let's just do a little bit of rehearsal. Let's say this rule specifically. I think that'll be enough. You can complete the rest. How should we update accordingly? Okay, this one here. Right? Potentially, we should really update the entry for term prime and also factor, potentially. Right? And now, should we, what should be term prime? Should we update it? The follow of term prime should be the follow of term prime. Well, nothing to update. Right? And term prime, by the way, is actually over here. It is nullable. Notice that. Okay? It is nullable. Okay, let's figure out the last one. Factor. What should be the follow of factor over here? Apparently, it should include always the first of term prime. The first of term prime will be multiply and divide. Multiply and divide. Should we also include the follow of term prime? Should we? We should, because term prime over here is also nullable, right? Term prime, that's something that we will calculate a little bit later. So you can rely on the further computation. Further iteration. Okay, so and etc. Okay, continue with this trend over here and complete the table. And how can you compare your answer? To find the answer, you will see that it's right over here. Okay. Okay, right here. Important exercise for you, and then I'll give you some extra as a PDF later. And we'll go over the answer on Tuesday. Start the table with empty, like what I did, and then you can feel free to go with this particular order of the variable. Make sure after you have completed the tracing, the computation for the follow, you will actually see exactly the result like that. If you can see that result, then that means you really got it. Okay, that's something I'll leave to you guys. Okay. Okay. All right, I think that's about all. Oh, well, we got one more computation to do, which is not too bad. Okay. Let me look at the time. Okay, we got about 5 minutes. Okay, how about we just go on with it quickly. Okay. That's the okay. So backtrack-free grammar. Okay. So this backtrack-free grammar, we're going to look at the one simple look ahead. And given that we talk about the first and also the follow, now we are actually going to combine them together in a way. So we have a new algorithm. But luckily, the algorithm looks just like what we had before. There's only a single line I had to change. Only a single line, which I'll show to you. Okay? Let's go over just some bullet points, and we'll show you the algorithm. So this will be the final set you guys will have to know for top-down parsing. Remember, we talk about first, we talk about follow, and this is called start. Okay? The start set is basically going to be a combination of the first and the follow. Okay? How are they combined together? Let's go over the definition here. I'll give you a little bit more hints about how you can interpret that. Okay. Okay, so this will be the ultimate definition we have to use in the algorithm. So in the actual algorithm for the backtrack-free grammar, you don't have to mention first and also follow at all. You just mention the start. That's all you mention. Okay? Whenever you're given certain grammatical rule, how can I know the start symbol conceptually? Okay? So now basically you want to say if this particular right-hand side, We want to know whether or not it is nullable. If it is nullable, okay, so this is when beta is nullable. If it is nullable, that means we should really look at the first of beta and also the follow of beta. Both. The first and the follow. Of course, the follow of beta will just be the follow of A, of course. Okay? That'll be the first case. On the other hand, if the beta is actually not nullable, is not nullable, in that case, we just don't need to worry about its follow because you cannot really go through the wall to see that. So that would just be the first of beta. All right, think about this definition. It's actually still following the same intuition as we said before. Okay? And so there is one property about the backtrack-free grammar. So later on, if we ask you about, given a grammar, is it really backtrack-free? All you got to do is to check to see whether or not this particular rule is actually satisfied. And don't be too terrified. Actually, say something very simple. If you choose any two rules in your grammar, any two productions, if their calculated start symbols simply do not really overlap, in that way, you know that the grammar is backtrack-free. That means you can always have the look ahead unambiguously. Okay, that's what it means. So here, between any two productions rules, we can always unambiguously choose one. Unambiguously choose one. Always. And of course, you will be only convinced when you actually see something that's actually not backtrack-free. That's something we'll show to you. Hopefully we have time. We'll see. Okay, just a few minutes. Okay, so review this definition here and also review this property, right? This property, we don't need to prove it. Just something you can take for granted. More like a definition. Okay? Okay, and then, let's look at the final algorithm. We don't need to trace it, don't worry. I just want to show you the final algorithm. Okay? And of course, for your assignment number 3, you didn't really have the computation for the start set using first and follow. If you really want to use that one, feel free. That's okay. I don't mind. But you really don't need to. Okay? But let's now take a look at the final algorithm. The only line that we have changed is this line here. Basically, only this line. Look a little bit close. Oh, let's look a little bit more closely over here. Okay, only this line. And this line over here, remember maybe about 2 or 3 lectures ago. This line here is really to say if you got any production rule that's unvisited, we haven't really explored that, before you use it, look at what's the start look ahead symbol for that particular production. If that one matches the word you're matching, you're supposed to match. In that way, you can choose it. Otherwise, don't choose it. With this look ahead, we can basically avoid the possibility of backtrack. I'm still putting them there, but without rewriting them. But just remember, this is how you can avoid the backtrack, because you can always choose the rule that's going to work. Okay? Always choose the production rule whose start symbol matches. Right? That's how we can avoid backtrack. Okay? That's the only thing I would like to highlight. Okay? Okay, good. Any questions so far? Okay? It's just about time. Okay? There's just 1 or 2 more small items I would like to talk about on Tuesday to conclude the lecture. But I'm going to release some extra exercise for you guys to really make sure you understand about the computation. Okay, I'll release them and then we'll go over the answer the first thing on Tuesday. Well, make sure you really understand first, follow, and start sets. And I'll see you on Tuesday. Okay? You'll also receive more information about the milestone too.